Now let's get into this figure 7-2. But before we do, I know I've reminded you a number of times, but it's kind of important to us. If you like our videos and you think they're helpful to you, well, hit that subscribe button for us and give us a little helping hand here so we can keep the videos coming to you. But now let's take a look at determining the primary voltage, primary amperage, primary turns, as well as the secondary. We get questions about this occasionally, but I've received about 2 or 3 here just lately. So I thought, well, why not go over it with you? Now, notice in the formula symbols, we have EP, primary voltage, ES, secondary voltage, IP, primary current, IS, secondary current, IP, primary turns, TS, secondary turns. And then notice the transformer, we have 10 kVA, and multiply that by 1,000, get rid of the K and get it into VA, that'd be 10,000. And then we have a 480 volt primary and a 240 volt secondary, and we're going to work from this. Our impedance is 1.5. So, for example, on the 240 volt side, we have about 52.5 amps, as you see at the very bottom where we find secondary amps, right in the center where we're finding amperage. If we took 52.5 and divided it by 1.5 as our percentage, we would come up with approximately about 3,500 amp short circuit current right there at the terminals. So keep that in mind. And so if we're finding the voltage in the primary, then it'd be EP, and that would equal ES times IS divided by IP. So when you insert your 240 volt, that's the voltage in the secondary, times 52.5, that's the amps in the secondary. And then we divide that by 26.25. When you take 480 volt into 10,000, you'd come up with that 26.25. And since 240 and the 480 is a 2-to-1 ratio, you could take 2 times 26.25, and that'd give you 52.5, the amps on the secondary side. Or take the secondary side at 52.5 and divide by 2, and that would give you 26.25 on a primary side, just using the ratio. See, a lot of times electricians, they do that. So notice when you do your math and everything, then the voltage in the primary is 480. And that's just exactly how you would find that. Now, to find the primary amps, then you'd have amps primary is equal to voltage secondary, amp secondary, divided by the voltage in the primary. So when you insert those values in, divide it by 480 volt, you'd come up with 26.25. That'd be your primary amps based upon 480 volts. See? Your turns now mean a lot on how your amps would be and your voltage would be in relationship to primary and secondary. Let's look at the primary. The turns in the primary would equal to voltage in the primary times turn in the secondary divided by the voltage in the secondary. So you insert that in, 480 times 800 amp, 800 amp turns of 800, divide that by 240, and when you do your math, we'd come up with 1,600. See, that'd be in the primary. So it's 2-to-1, isn't it? 2-to-1. You just take the 800, multiply it by 2, that's 1,600 in the primary. Take the primary, divide it by 2, and that would be 800 in the secondary, see. So now when we come down and take a look now at the secondary voltage, you would have the voltage secondary is equal to the voltage primary times the current primary divided by the current in the secondary. So inserting those terms in, 480 volt times 26.25 divided by 52.5, and when we do the math, we come up with 240 volts, and that's in that secondary. Now, secondary amps, you do the same thing. You just use the formula, current in the secondary, voltage in the primary times the current in the primary divided by the voltage in the secondary. And when you do your math, you come up with 52.5 when you insert those values based upon the symbols in the formula that you see to the left there of the transformer. And in the secondary turns, you'd have transformer turns in the secondary, voltage in the secondary times the turns in the primary divided by the voltage in the primary. And then when you insert 240 times 600 divided by 480, do the math, we come up with 800 turns. And since it's a 240 into 480, 2 to 1 as we mentioned, 2 times 800, see, would give you 1600. And so basically it's a multiplier on the secondary side, that 2 to 1 ratio, and it's a divider on the 480 volt side. See, so this gives you transformer principles based upon voltage, amperage, and turns, as you see is illustrated, and that's what this figure 7-2 is illustrating. When we want to know certain things about the transformer principles.